Hey guys, ScannerDanner here. We are working on what, 2013, I think it's a 2013, yeah, Chevy Impala LTZ. The complaint with this vehicle is it is a no start. A little bit of history behind this. And I actually have some video on this, but you guys never saw it because I was never able to reproduce the complaint of the wipers that intermittently would not work. Of course, that complaint, when it got here to the shop, we had tried over and over and over again to make it not work. And I actually got it to do it one time. And then in the process of getting my equipment together, it started working again. And I don't remember exactly what made me suspect the power distribution box. This is an intelligent power distribution box, IPDM, and so that just means that it has a module inside of it that talks on the CAN network. And that was my suspicions, but I couldn't prove it. Anyway, long story short, this vehicle is now a no start. It was towed in, and apparently someone, before it got towed in, had messed with all of his fuses. At least this is what we're told, that they pulled all the fuses out, put them all back in, and then the car started up and ran. And I'm not sure how long he drove it after that, where it died again, and it's now here as a no start. So my suspicions are in relation to this IPDM. I don't know exactly where this is going to take us. I did scan this ahead of time before I turned the camera on, and I do have some low voltage codes related to the ignition switch circuit, and there's 2 power feeds to the engine computer. So let me show you these codes. I'll just do a quick scan for everyone. I'll let you guys see what I saw. Ignition relay, feedback circuit low voltage, and then ignition 1 switch circuit 2, the 1682. I did a little bit of homework on this on the 1682 code, and I'll get you guys to that in a minute. I want to show you what I was looking at on the data that is showing me low voltage. I'm just going to grab anything on here that's related to ignition voltage. Some of these PIDs I selected are not relevant, like the starter relay. But look at my ignition relay feedback voltage, it's 2.5 volts. So right off the bat, I think that's where our problem is. Now, what I could do is start, banging and wiggling on things, in particular with the power distribution box, but I want to get a little bit more familiar with the system that we're working on. And so what I want to do now is go to a wiring diagram and see what we can dig up as far as the ignition relay controls and make sure I'm not missing anything. All right, so starting with this 1682 code, ignition 1 switch circuit 2. What was the other code we had too? We had P0689. That's also in this list. Engine controls ignition relay feedback circuit low. Both of those codes, and it says conditions for setting the 689 says engine control ignition relay feedback voltage is less than 5 volts for greater than 5 seconds. And let's get back to scan tool here for a second. Ignition relay feedback voltage is less than 5 volts. We have that. We're at 2.5 volts on that circuit. That's definitely the one I want to focus on. The 1682 says there's greater than a 3 volt difference between ignition main relay signal and powertrain relay signal circuits for less than 1 second. So ignition relay, and I'm guessing it's that. I do have a battery charger on here now. That's why you're seeing 13.2 volts. You have to look at the spikes in this through a lens of the min-max scales. So it looks like there's a lot of movement there. There really is not. All right, there's not a whole lot of info on the code. It just says the powertrain, this is important info, the powertrain relay may also be labeled the engine controls ignition relay, EC ignition relay feedback, the engine control module relay, or main relay. Thank you. Ignition main relay may also be labeled the run crank relay, ignition 1 relay, the ignition run relay, or ignition relay. That's nice. Circuit description, there are 2 ignition voltage circuits supplied to the engine control module. One is supplied by the powertrain relay, the other is supplied by the ignition main relay. So I'm interested in that circuit. So we could start, I think, with the engine performance wiring diagram. All right, so what I'm looking for is, I'm looking at this one. That says hot with ignition main PCB. That's printed circuit board relay. So that's part of the power distribution box. That's going to be ECM ignition fuse 10 amp. That is the underhood fuse block right side of the engine compartment. Really doing a quick voltage measurement there would be helpful. Although my ignition 1 signal shows me 13. That's ignition voltage, so that should be good. Ignition relay feedback. All right, let's see here. Hot all the time. That's the cluster fuse. So that just goes to my evap canister. All right, next page. So the powertrain relay on the diagram is the underhood fuse block, right side of engine compartment. That's part of it. It looks like that's part of it. And that's going to feed power to ignition 1 fuse, ECM fuse, ignition 2 fuse. All of these guys, we can do some voltage measurements there. And all of these fuses, as my son will be the one editing this, so I'm going to talk to him for a second. This whole circuit here is going to be powered up by this powertrain relay. As soon as this 30 and 87, this switch closes, it's going to power all those. So we can do voltage measurements on those fuses if we need to. Definitely interested in this feedback circuit too. So I don't see any other circuits. Just if we go back to diagram 1, you see the hot with ignition main PCB relay energized. This ECM ignition fuse. And then I'm definitely worried about the powertrain relay. And then what I want to know is this EC ignition relay feedback. So can I get a data pin for that? Or a pin on the computer? In the flowchart, pretty much sucked. What is ignition vol? What is that? VOL. Pink and black, 14 and 15. All right, yeah, that comes from those circuits. Let's do a couple of quick checks on these fuses. Ignition 1, ECM, ignition 2. Let's do a couple quick voltage measurements. So I'm on the passenger side. This is passenger front area. Kind of keep our eye on this ignition feedback circuit as I pull this cover off. See if we get any changes. Just kind of give us some direction as to maybe where our fault is, if it's in this box or not. Pull up a separate meter tab. To do that on the Veris, what you do is you go to home, go to the guided component test meter and pick something. It doesn't matter what it is. I mean, it does to a point, depending on if I want my graphing meter or not. I'm just gonna pick my crank sensor. Signature test, view meter. Now what that's gonna give me is a separate meter window that you're looking at right here. I'll show my desktop so I can see it. Minimize that, you see that show up down there at the bottom. Hit the home tab, back to the scanner. So I got the digital number showing up here too. So we'll look at, that's not the greatest view for what we're doing, but I'm really looking at that live number right there. And I just wanted to watch my feedback circuit while I'm doing this, so that's why I pulled it up that way. I gotta find these circuits. Let's turn this off. Get this out of the way. I just turned the charger off. That's why you see that battery voltage dropping on the scan tool. This is my powertrain relay right here. So it's not integrated, the powertrain relay. Then you have your vacuum pump. This is your AC compressor. And then ETC fuse is the first 15 amp fuse. The one underneath that is ignition 1, according to this. This should be the ignition 1 fuse. Nice. It's reading 2.5 volts, exactly the same as what the scan tool shows. 2.5 volts on that. And the one below that, you know, there's really no reason to check both sides of the fuse, just given the symptoms. I can do that. I'll show you the other side's gonna be the same, 2.5 volts. Yeah, 2.5. And then the emission fuse, that's also fed by the same circuit, 2.5 volts, 2.5 volts. And then ignition 2, 2.5 volts, 2.5 volts. This last one here is emission 2, really going any further. They're all showing 2.5 volts down that line. So back to the laptop for a second. So what this means to us is that comes from the powertrain relay, and there's a hot all the time circuit that also feeds. So I'm concerned, let's take an image here so I can draw on it. All right, so These are low voltage. We have 2.5 volts on all of these fuses. Okay, our feed's gonna come in this direction. We need this switch to close. Control side of the relay is really not my concern because we have voltage here, which tells me that this is most likely closing. So this switch is probably closed. We're just gonna assume that for a second. And that means that our low voltage is back this way. And what I wanna make sure of is that this circuit that I just drew is good. And the way I'm gonna do that, I'm gonna check this fuse, this ECM, TCM fuse, that you're gonna have a power feed that comes in here that's hot all the time that we have not identified on this diagram. And that is one of my concerns. And the way I'm gonna check that feed is if I have good voltage on this fuse, that's gonna tell me that up here is good. So let's do that first. ECM, TCM fuse, 15 amp. And that is in the same location of where we are. ECM, ETC, that's the top one. I think it might be this one. That's 2.5. I just gotta make sure, because this says ETC/ECM, and on the diagram it said ECM, TCM. Oh, there's separate location. ECM, TCM is right below the starter relay, so it's this one. This fuse is gonna answer my question on this box or on this main feed. Yeah, so we have 12.2 volts on that fuse. Okay, so what that means is this circuit, this is good. Okay, now we gotta make sure that this really points to a bad relay right off the bat, like a contact issue here. You could potentially have a problem in this leg of the circuit. It's so unlikely for that to happen because it's inside the box. I mean, it could be. Could we make the argument that the control side of this relay is not being grounded? I don't think so. Be nice if I could get underneath and show you. If you could get to the bottom side of this, what you would do is you'd want to see, these would be the numbers you'd want to see on a working circuit. You'd want to see this. 12 volts here, 12 volts here. This would be with the circuit energized. We'd want to see 0 volts here because this is a ground side switched circuit. I know that down this way is going to be a switched ground because you have power up here. And what does a coil of wire need to work? It needs power and it needs a ground. Okay, so I know for a fact this is a ground side switch circuit. So 12 for the control power, 12 for the load power, 0 telling me the circuit is being energized. This would be making a magnetic field. This switch would close and we should have 12 volts on this side of the circuit. What's a bad relay gonna look like? A bad contact is gonna be what we see, 2.5. It'd be 12 here, 12 here, 0 here, 2.5 here. But because I can't get underneath it, we can't really show you the checks that I'd like to do. I think at this point, I'm just gonna wiggle this relay smack on it a little bit. That'd be this relay right here is my powertrain relay. So I'll just kind of wiggle it. There you go. Look at my voltage. We just spiked up to 11 volts momentarily. Now the question is, would this be a relay problem? Or is this a box problem? So there's your 12 volts. Car's gonna start now. 12 volts on that, and then also we should have 12 volts on this fuse too. Yeah, you see the same thing. All right, so we're gonna swap this with the vacuum pump. This does have a vacuum pump. I'm gonna swap it with the vacuum pump relay. Look, still have low voltage, so we got an issue in the box. It's inside the box is our problem. And this would explain the wiper circuit. I hope you guys see what I just did. I just swapped relays and I still have the same problem in this location. He needs this box. Hey Pete, can you come over here and see if this will start? Yeah. It needs this power distribution box. I'm just holding tension on the side of the relay. And then I wiggle this. See, current flow can keep a circuit latched. Can you turn the key back on? I did, yeah. Keys on? On. Yeah. You shut it off. Just turn your key back on. That's all I needed to see, Pete. So now duplicating this fault's difficult, but we definitely have something inside the box. And really what proved that is the main feed was the ECM TCM one, and that was good. You know, these older ones, you should try snugging these bolts up. I remember on an older GM where you had like loose bolts from this. Do you have an 8mm? Does that look like an 8 to you? Yeah. I want to snug these up. Bad part about something like this is the more you wiggle, the more you fix the issue. Could just be pin contact too. Loose pin. You can hear the relay clicking. Here, listen. No, it's not a control side issue. I wonder if that one pin is just spread apart a little bit. It's not an 8. You were smart and brought your whole tray over.
That's what you did.
Nah, these weren't loose, Pete. The downside of what I just did is, as you unplug and plug it back in, you know, you kind of make it contact again. You need to replace this box. I'm not pulling it apart. This is the same box I was worried about, Pete, with our wiper circuit. There we go. Look at your voltage. And this is not a relay issue because I swapped it. This is your air pump relay, and this is your PCM relay. So we have a contact issue in this box. And I believe this is the same box I was worried about when this thing came into us with the wiper circuit. I remember that being part of the equation. All right, so before I go away from this page, let's just make sure that you guys all understand what I was doing. The fact that, again, this fuse was good, showing me 12 volts at the same time that I'm reading 2.5 volts down here, tells me my supply coming in is good. It's good. Okay? So we don't have a question. This supply coming in is good. All right? You can hear the relay clicking. That'd be the control side working. I'm not worried about the ground over here. We have a voltage drop that is occurring from, let's change our color. Here, this is our options for faults here, is our voltage drop is somewhere in the orange leg of this circuit is where my voltage drop is. Most likely, from what I'm seeing, we have a loose pin either here or here. And the reason I say that is we swapped relays. We had the exact same problem. You know, the box really needs to come apart and probably have, I mean, a visual inspection is one thing, but I believe there's other issues with this box. The reason I don't want to go in and do this is because we had a wiper circuit malfunction on this. And I remember tracking it down to the underhood fuse box. I want to see my wiper circuit again too. Yeah, hey Pete, come here. Here's why I'm not going into the underhood fuse box on this to try to tighten the pins up or whatever. Look at your 2 wiper relays, actually 3 wiper relays. Where are they? It says PCB relay, that's printed circuit board relay. So underhood fuse block, right? Right there, right? Same thing, wiper circuits were not working intermittently. I'm not messing around with this box. All right. If it wasn't for the fact that this was in with a wiper circuit issue in the past.
Right, it got more problems than just
yeah, I absolutely.
Well, I got the wiper circuit, and then this after tighten up whatever.
But surprisingly though, I thought that this was.
The wiper's been working.
Right. But I thought that this was a intelligent power distribution box, and it doesn't look like it is. There's the BCM and the wiper switch. No, there's no data that's going to this for the wiper circuit. Okay, BCM's controlling it. All right, let me do one more thing. Power distribution. Right side of engine compartment, underhood fuse block. So it is just it has a circuit board in it. Oh, that's right kick panel. No, this one, the top one, underhood fuse, right side, underhood fuse block, just fuses there. The second one is right kick panel fuse block. right kick panel, under hood. So ICM main PBC relay. So that's printed circuit board relay, but that doesn't mean it's a smart fuse box. In other words, we're not gonna have to worry about programming with this thing. All this means is this ignition main PBC relay, it has a relay that's part of a printed circuit board that's inside of this thing. Yeah, we got all kind of relays inside of here, Pete, that are part of it. High beam, low beam, DRL. Yep. There's no CAN lines that go to this. I was incorrect in my assessment of the circuit design. There's other relays that are inside of this, but it should be, this is just a plug and play type thing. We can maybe try to show that. I really think that pin's loose. But again, guys, the reason we're not really gonna try to fix that is because of the wiper circuits that were intermittent and all the circuit boards that are inside of that, or I'm sorry, all the printed circuit board, PCB relays that are inside of this. All right, I'm shutting this down. All right, so off camera, while I was looking at another car for Pete, he had unbolted this, so it's pretty straightforward. Just disconnected the negative terminal of the battery, and then you know, the positive bolt eyelet on the top, and then these 4 bolts, and then it unbolts the main connectors underneath. And it's really, in my opinion, a non-serviceable box. It's not really made that I can see to come apart, but you can see the green part underneath. Let's see if I can zoom in on that a little bit. That there is, in fact, a printed circuit board underneath here, and there's going to be relays inside. And again, I think really the issue is just loose terminals. Like that relay is super loose. That's the PCM relay. I believe that tightening of pins would have been something that maybe could have been done if you were wanting to maybe save yourself a couple bucks. It's not a really expensive part. I think Pete said it was around $200 for the piece. I've seen a lot worse. And so again, this is not, from what I saw through research, this is not an intelligent power distribution module, even though it has a printed circuit board. So it's not on the CAN network. Pretty easy diagnosis really with this one. Yeah, look at that. Look at the difference with this relay compared to this one. Loose pin contact. It's getting a new box, and that's pretty much it. So will I come back and show you the car running with the new box? I don't think I'm going to on this one. I showed you guys what I did when I pulled on the relay, and I made the car start and run. And the fact that, again, the wipers were an issue as well. I think I have some footage from that. Maybe I'll try to throw some of that in here and what I was fighting with the wiper circuit. I don't remember if I saved it or not, but pretty easy diagnosis on this, even though it's a unfamiliar system to me. First time I ever worked on one. As long as you understand voltage drops and things like that is all you really needed. A good wiring diagram, of course. For those of you watching this, you want maybe access to the same wiring diagrams you saw me use in this video. There is a DIY version of Mitchell. This is Mitchell On Demand or Shopkey. I use a professional program. It's $170, $180 a month, but there is a DIY version where you can pay for access. Let's say that this was your car and you wanted to fix something like this and you needed good diagrams. Well, you can pay $20 for around 30 days. Yes, it's like $19.99 for 30-day access to wiring diagrams, flow charts, all the stuff you guys saw me use in this video. And it's called Mitchell One DIY. I will put a link for that in the description of this video so you guys can get access to the diagrams I was showing you. So hope you learned something on that one. Thank you guys so much. I'll see you next time.